Hello everyone, in this video we're going to explore topic 9.9 of AB Calculus BC. Find the area of the regions bounded by two polar curves. Remember, the area in polar coordinates is given by 1/2 integral from a to b of f of theta square d theta. Alright, example number 1, given two polar curves right here. This one is the equation of the circle. Alright, and this one is the equation of the cardioid. So if you graph these two guys on the calculator, you will get a picture on the right hand side right here. Alright, so the area of the shaded regions is the whole thing right here. And remember that this guy and this guy right here symmetric about the polar axis, right? So basically you just calculate the area of one regions and you just multiply by 2 to get the whole thing, right? Now, for the upper one right here, this one includes two portions, right? The one is the pink one right here, and the second one is the gray one right here, right? The gray one is bounded by the circle, right? And the line theta equals 2 pi over 3. And the second one is bounded by the cardioid right here. And two lines, it could be theta equals 2 pi over 3 and theta equals pi. Right? Now, how do we find 2 pi over 3 and 4 pi over 3 right here? These two guys actually the intersection of the cardioid and the circle, right? So you just equate this guy right here and this guy right here to find the angle theta, right? So we have negative 6 cosine theta equals 2 minus 2 cosine theta, right? So this guy turns out to be negative 6 cosine theta plus 2 cosine theta equals 2, right? So negative 4 cosine theta equals 2. And cosine theta equals negative 1/2, right? And theta equals 2 pi over 3 and 4 pi over 3, right? Now, we need to calculate the area of this shaded region right here. This is A2, right? So let A2 equals 1/2, right? I'm going to use the formula right here. Draw from this guy right here, actually pi over 2 to 2 pi over 3, right? Now, this guy is bounded by the circle, right? So we're going to use the equation of the circle. So negative 6 cosine theta square d theta, right? Press menu calculus integral from pi over 2 to 2 pi over 3. So I'm going to press this button right here to put a fraction, right? So here's the pi over 2. And hit this button right here, put a fraction. And this is 2 pi over 3. So 2 and pi here over 3. Of negative 6 cosine, you just press strict right here, cosine, and press pi, put theta right here. And then this one square, d theta. Don't forget to multiply by 1/2, right? And press enter. The answer is 3 times 2 pi minus 3 root 3 over 4. Now, to calculate the area A1, we're going to use the same formula, right? So 1/2. Now, A1 is the integral from 2 pi over 3 to pi, right? In this situation, we need to use the equation of the cardioid, right? So it's going to be 2 minus 2 cosine theta square d theta, right? Then we're going to print up the calculator. I just copy this one over here and just change the value, right? So this one is 2 pi over 3. And this one is just pi of 2 minus 2 cosine theta and press enter. The answer is 4 pi plus 9 root 3 over 4. Alright, basically you just add them up, right? So A1 plus A2 equals 3. Distribute this one, it could be 6 pi minus 9 root 3 over 4 plus 4 pi plus 9 root 3 over 4, right? So it's going to be 10 pi over 4, right? And then don't forget to multiply by 2 to get the bottom one right here, right? So now you're going to take 10 pi over 4 times 2. This one is the error of the whole thing, right? So it could be 10 pi divided by 2, it could be 5 pi, right? Now let's take a look at example number 2. Find the error of a region between two curves. Find the error that is inside the limation 3 plus 2 sine theta and outside the circle r equals 2. Alright, so here's the equation of the circle r equals 2. And this one is the limation. Now what you need to do is to find the intersection between two curves. It's going to be right here and right here, right? So basically you just equate this guy and this guy, right? So I have 3 plus 2 sine theta equals 2, right? So sine theta equals negative 1/2, right? And theta equals negative pi over 6 and 7 pi over 6, right? So this one is negative pi over 6 and this one is 7 pi over 6, right? Now observe that this guy right here and this guy right here, they're both symmetric about the y-axis, right? So basically you just calculate the error of 1 and you multiply by 2, right? Now in order to calculate the error of this shaded region right here, I need to calculate the error of the limation right here and subtract the error of the circle right here, right? So the error of the shaded region equals the error of the limation subtract the error of the circle, right? The error of the limation is 1/2 integral from negative pi over 6 to pi over 2, right? Of this one right here, square, right? 3 plus 2 sine theta square d theta, right? So I'm going to print up the calculator, copy this one over here, and I just change the upper bound, lower bound, right? Negative pi over 6 to pi over 2. 3 plus 2 sine. Then you just press enter. The answer is 11 times 4 pi plus 3 root 3 over 12. Now the error of the circle is 1/2 the integral from negative pi over 6 to pi over 2, right? Which is from here to here. Now we're going to use this one right here, right? So 2 square d theta, right? So this guy turns out to be 4 theta over 2, evaluated from negative pi over 6 to pi over 2, right? So 4 theta over 2, it could be 2 theta, right? So we have 2 times, substitute pi over 2 for theta, so it could be pi over 2 minus negative pi over 6, right? So I'm going to simplify this one. It's going to be 8 pi over 6 or 4 pi over 3, right? Now, the error of the shaded regions is this one right here and distribute this one. So I have 44 pi plus 33 root 3 over 12 minus 4 pi over 3 right here, right? And multiply the top bottom by 4. So I have, so it could be 28 pi plus 33 root 3 over 12, right? Now, you need to multiply this area of the shaded regions by 2, right? So multiply by 2. So it's going to be 28 pi plus 33 root 3 over 6, right? Now remember that example number 1 and example number 2 can be calculated without using a calculator, right? Example number 2, very simple, you just use complete square formula and you expand this one, right? And remember we have sine square theta equals 1 minus cosine 2 theta divided by 2. Now for the first example right here, you have cosine square theta equals 1 plus cosine 2 theta divided by 2, right? Now let's move on to example number 3. This one is the AB style free response questions. The graph of the polar curve R theta equals theta times sine theta times cosine theta is shown in the figure above. For theta from 0 to 5 pi over 2, right? This one is 0 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and this is 4 pi over 2, which is 2 pi, and go back over here, it's going to be 5 pi over 2, right? Let's add the shaded regions in the outer loop of the graph of the R theta and also outside of the inner loop of R theta, as shown in the figure above. Let R be the regions bounded by the graph of R theta in the quadrant 4. So this guy right here. Find the area of R. Alright, so we need to find the lower bound and upper bound of the interval first, right? So what's this and what's this? Now, be careful. The common mistake students always make, they say 3 pi over 2 and 2 pi. However, that's not the case. You need to rewrite this function right here. R theta equals 1/2 theta sine 2 theta, right? Because you have the double angle formula sine 2 theta equals 2 sine theta cosine theta, right? So you need to determine the sine of the radius right here, okay? So you know that the unit circle has the y-axis represent the sine function, the x-axis represent the cosine function, right? So anything above the x-axis, it could be positive value for the sine function, right? Anything below the axis, it could be negative value for the sine function, right? And you know that this guy is 0, this guy is pi over 2, this is pi, and this is 3 pi over 2. And go back over here, it could be 2 pi, right? Now, sine 2 theta is positive for 2 theta from 0 to pi, right? So 0 less than 2 theta less than pi, right? And you solve this one, so theta is going to be greater than 0 less than pi over 2. Now sine 2 theta less than 0 when 2 theta greater than pi less than 2 pi, right? Now divide both sides by 2, so it could be pi over 2 less than theta less than pi, right? Now the third one, sine 2 theta greater than 0. Alright, if 2 theta greater than, this one is 2 pi and this one is 3 pi, right? So it could be 2 pi to 3 pi. Divide both sides by 2, so it could be pi less than theta less than 3 pi over 2, right? Now the last one, sine 2 theta less than 0 when 2 theta from 3 pi to 4 pi, right? Now divide 3 sides by 2, so it could be 3 pi over 2 less than theta less than 2 pi, right? The sine of the radius right here depending on the sine of sine 2 theta, right? So this guy make the radius positive. This guy make the radius negative. This guy makes the radius positive, and this guy makes the radius negative. Now remember, in the polar coordinate, when the radius is positive, the point r theta lies in the direction of angle theta. When the radius is negative, the point r theta is plotted in the direction of theta plus pi, which is directly opposite, right? If you look at this one right here, the interval from pi over 2 to pi, right? Which is this guy right here, quadrant 2. Sine 2 theta less than 0. This guy makes the radius less than 0, right? Because the radius is less than 0, the point r theta is plotted in the direction of theta plus pi, which is in the quadrant number 4 right here, right? So the regions R right here receive the lower bound and upper bound pi over 2 and pi, right? Now go back over here, we have the integral from pi over 2 to pi, right? Of theta sine theta times cosine theta square, right? D theta. Don't forget to multiply by 1/2, right? By the way, I'm going to show you how to graph this polar curve on the polar coordinate using the TIN SPY calculator. Alright, so you're going to print up the calculator. Now, you're going to go to menu number 3 and you pick polar right here. Alright, so you're going to pick theta, so you'll press pi here, put theta times, make sure you put the multiplication right here, and then hit trick right here, put sine, then theta times cosine theta. Alright, then you press enter. It's going to be right here. See that? This one. Alright, so I'm going to go to home screen. I'm going to press calculate. Now press menu, calculus, integral. Don't forget to put 1/2 in the front, right? So press this button, put fraction, and then it's going to be 1/2. The integral from pi over 2 to pi, right? So you're going to press fraction right here, put pi over 2. Theta times sine theta times cosine theta square d theta, and you press enter. It's going to give you exact value right here. Now if you want to convert this one to decimal, you just press Ctrl enter, and it's going to be 0.552947, right? Now let's move on to the next one. Find the error of the region S right here. The region S right here is the shaded one right here. Inside the bigger better. And outside the smaller better right here. Right? So this guy actually the error of the bigger one subtract the error of the smaller one, right? So you have error of the region S equals 1/2. The bigger one, which means from 2 pi to 5 pi over 2, right? Integral from 2 pi to 5 pi over 2 of theta sine theta cosine theta square d theta minus the smaller one, which means 1/2. The integral from 0 to pi over 2, right? The smaller one is right here, right? It's going to be from 0 to pi over 2 of theta sine theta times cosine theta square d theta, right? Now we're going to print up the calculator. Alright, so I just copy this one over here. I just changed the lower bound and upper bound. That's it, right? 4.844, right? Now let's move on to question C. For theta from pi over 2 to 3 pi over 4, r of theta less than 0 and dr over d theta less than 0. What do these facts say about the curve relative to the origin? Alright, so we're gonna go back to this one right here. We know that theta from pi over 2 to pi sine 2 theta less than 0. Then the radius is less than 0, right? The points on the polar curve are in quadrant 4, right? Actually, it's in quadrant 2, but the radius is less than 0, right? So you need to take the opposite one, which is in quadrant 4, right? Now, the question gives you the interval pi over 2 to 3 pi over 4. Pi over 2 to 3 pi over 4 is going to be inside of this interval, right? So it's going to be in the quadrant 4, right? Now, because d r over d theta less than 0, points on the polar curve moving away from the origin. Now let's move on to question D. For the closed interval pi over 2 to 3 pi over 2, find the greatest distance from any point on the polar graph of r theta to the origin. Justify your answer. Alright, so in this situation, we're going to use the candidate test, right? So first, we need to take the derivative of the function r theta equals theta sine theta cosine theta, right? So we're going to print up the calculator. Now we're going to grab the derivative of this function, right? So we're going to press grab right here. We're going to press menu, go to grab, go to function right here. You're going to press tab, the function f1 as equals derivative, right? So you're going to press this button right here, right? So you have derivative, it's going to be right here. Alright, derivative with respect to s, right? And I just press enter, it's going to be right here, right? Now I need to restrict the domain, right? The domain is from pi over 2 to 3 pi over 2, right? So you're going to press menu number 4, number 1. Alright, s minimum is pi over 2, right? So I just press pi divided by 2. S maximum is 3 pi over 2. So it's going to be 3 times pi divided by 2, right? And I just press OK. So it's going to be right here, right? Now you have two critical values right here, right? This is where r prime theta equals 0, right? So I need to find the critical values right here. So I need to press menu number set 0 right here. You need to find 0, right? So go to the left of 0, go to the right of 0, you get 2.46. Now, similarly, menu number set 0, left, right, it's going to be 3.99, right? So, I need to use the candidate test, right? The first value is right here, the endpoints right here, pi over 2, right? The next one is this guy right here, 2.46. The next guy right here, 3.99. And the last one is 3 pi over 2. For pi over 2, you just substitute back over here, right? You know that cosine pi over 2 equals 0, right? So you don't need to use a calculator for this one, right? This guy equals 0. Now, 3 pi over 2, cosine 3 pi over 2 still 0. So this guy 0, right? Now, 2.46. I'm going to go to the home screen. Press calculate, right? Now, I need to store the function, right? Press R parenthesis theta. And then you press Control and this put in right here. Alright. It's going to be theta times sine theta times cosine theta. Alright, so you press enter. Whenever you see done, which means you successful, right? Remember, the distance always positive, right? So you need to put the absolute value, right? So you're gonna press the button right here. The absolute value side is right here, right? Then you just put R of 2.46. Then you press enter. It's gonna be 1.203, right? Now you do exactly the same thing for the second value. It's gonna be 3.99 right here. And press enter. It's gonna be 1.979, right? So I have right here 1.203 and it's gonna be 1.979. Now the radius distance is 1.979 when theta equals 3.99. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand